Okay, so I'm going to get started with this next webinar, the series of webinars we've been doing this year. So the topic of this webinar is looking at sensitivity analysis. If you've missed any of our prior webinars, they're all on our website, and I'll go through that at the end again with you. And you can catch up with them sort of any time that you need to. They're just listed on the website. So in this particular webinar, what we're going to do is we're going to look at examining uncertainty in model inputs, specifically looking at univariate sensitivity analysis, so looking at varying one input at a time. So if you look at things like the ISPOR or the SMDM Modelling Good Research Practice Task Force guidelines, it talks about sensitivity analysis really serving two main purposes. And one of those is allowing you to assess the confidence in your chosen strategy. And the other one is sort of assessing the value of collecting additional information to be able to inform your decision-making process. So basically, whenever you model, sort of doing some sensitivity analysis is usually required. So in TreeAge Pro, you have the option of both doing deterministic sensitivity analysis, which we'll do some of today, and then we'll also be looking at doing probabilistic sensitivity analysis as well, and that will be covered in a later webinar. I think it's the next one in the series at the end of August. So we're going to focus with deterministic sensitivity analysis in this particular webinar on two items. One's going to be looking at varying a single parameter just via one-way sensitivity analysis, and the other will be presenting a series of one-way sensitivity analysis results for different parameters in the tornado diagram. At the moment, I've got all your microphones muted, or you've muted yourselves to reduce background noise. If you've got any questions, please submit them via the chat window. So I'm just going to type, please submit questions here if you have some. So you can all see where the chat window is, and I'll address those either going through the presentation or as we get to them. And if we don't get to your questions, just email any questions to support@treeage.com, and I can sort of answer those after the webinar as well. Okay, so what do we want to do first of all? So in sort of any cost effectiveness model, when we're looking at the base case analysis, what that's going to do is identify for us an optimal strategy via looking at the ISA or the net monetary benefit calculations if we're using a willingness to pay. So for basically any pair of strategies that we're looking at, we could normally, when we run a rankings report on that cost effectiveness graph, if your ISA is less than your willingness to pay, we're going to choose the sort of the more expensive strategy, the more effective strategy. Whereas if your ISA is greater than your willingness to pay, you're going to choose the least expensive strategy. So what one-way sensitivity analysis will allow us to do is see how those model results, so your base case results, how they vary, how they change as you vary a parameter over a range. So usually we'd have usually what we do is we would have a range based on an uncertainty for a given parameter, and then when you vary that parameter over the range, it may or may not identify where the optimal strategy changes. If it does identify where there's an optimal strategy changes, we call that the cost effectiveness threshold. So we'll look a little bit more detail in doing one-way sensitivity analysis at that. So what sensitivity analysis may lead you to do is to invest a little bit more time, effort, money, resources in getting better estimates for your parameters and thereby reducing the uncertainty. Sorry about the background noise. We have an Air Force exercise going on in Darwin at the moment, so there are a lot of planes going over. So if it gets too noisy, I'll just stop talking and then I'll carry on. Okay, so we're going to use an example here, which is called the blindness prevention model after cost effectiveness changes. And if you look in your projects view under the healthcare models here, it's just an example model that we've just plucked from there. So it's blindness prevention after cost effectiveness changes. So this model, I'll just briefly kind of go over what's in here sort of orientate you to what you're looking at. You're looking at sort of 3 different treatment options here. So there's 3 strategies: treat none, a biopsy, and treat all. So in the biopsy scenario, what you have is you also have a screening test element in there, which results in a number of different outcomes. So you've got sort of 4 possible outcomes that can happen there. When you've got this screening test, you have true and false positives and negatives dependent on the disease prevalence, the test specificity, and the test sensitivity. And obviously, as usual, we have variables for those kind of things. So they're all sort of listed here in your variable properties view that you can access. Either it'll be in your views at the bottom here of TreeAge, or you can access it via your views menu here. When you select the drop down, it'll give you the variable properties view down here. Okay, so you can see that they've got different definitions here. Also, they've got root definitions for all those variables here as defined down here. So before we can do any sensitivity analysis, what I want to do first is just run the model and show you what the base case results are. So that way we'll know that when we change certain parameters, so we're varying them across the range, what that impact is on the base case. So all we want to do in this case is I'm just going to run the rankings report. So if I just go to the analysis menu and then select rankings, it's going to give me the rankings report. And what you can see is that of the 3 strategies, so treat all, biopsy, and treat none is absolutely dominated. Okay, so that's not a strategy that we're going to be considering as one of the optimal strategies here. So if we consider the results excluding the dominated strategy, then you can see here that we've got an ISA of 473.94. So in this particular case, let's assuming we have a willingness to pay of say 30,000, we would recommend the biopsy over the treat all. So in this case, we'd consider that the ISA is less than the willingness to pay in this particular example. So that becomes our base case results. Our recommended, we would recommend the strategy of biopsy over treat all. And so the next thing that I want to do is say, well, okay, so given that we have uncertainty around one of these variables, let's see if that is going to change the impact our results. So in the model that we've got here, what I want to look at changing the disease prevalence. So the prevalence of the disease in the population. At the moment, it's set as 0.5, which indicates that half of the population has the disease. So let's consider the impact of uncertainty related to disease prevalence, and we'll do that via one-way sensitivity analysis. And what we want to look at is, do the results change based on the prevalence, and will there be a strategy change in the uncertainty range that we're going to use for this disease prevalence. So to run one-way sensitivity analysis, it's fairly straightforward. You select the root node and you go to your analysis menu, and then there should be a subheading in there called sensitivity analysis, and that gives you a list of the different analyses you can run. And so we want to run one-way sensitivity analysis. So I'll go through this a little bit more slowly because it's the first time that I've run sensitivity analysis in front of you. So in the dialog that pops up here, you can see that there's on the left-hand side, there's a column which is called variable. And we're running one-way sensitivity analysis, so that means we're going to be only varying one variable. So what you get the option to do is select which of the variables within your model you want to do one-way sensitivity analysis on. So it happens that the model's set up already to run disease prevalence, so that's fine, but you could select any of the other variables too. Okay, so that's how you select the variable to run the sensitivity analysis on. Then there's a couple of other things to look at in here. Something else that's important here, you will only see listed in here variables that are defined at the root node, okay? So that is where you have to define variables that you want to use for sensitivity analysis as well. You won't be able to change things that are just set as numeric entries in your model. So if you don't use any variables, you just entered the raw values into your model, you won't have the option of selecting the variable here to do sensitivity analysis. So it's one of the main reasons that we'll need to do use variables in our model. And we'll note as well that if you have expressions, so for example, formulas, you can't do sensitivity analysis on the formula itself either. Again, only individual variables that are defined at the root node. So once you've selected the variable, you then get the option to put a low and a high value in there for the range over which you want the variable to change. So just, I guess, drawing your eye to the second column here, which says type. In this particular example, we're choosing to change the variable disease by values. So we go from a low value of 0 to a high value of 0.5 and over 4 intervals. So we'll just split that range into 4 intervals. But what we could do, we could actually select to adjust that variable by a percentage. So then what you would do is you'd say, how much do I want to go below or above the base case value of 0.5? And again, you'd put that in there, so 20% below and 20% above, for example, and then that would give you an appropriate range. Or you could choose to vary it by a value as well. But in this case, what we're going to do is we're just going to stick with varying it by values, but you do have that option to either go for a percentage below or above your base case, or a set amount below or above your base case. Okay, so that's really useful considering. Someone just asked me via question if we'd be covering microsimulation in this model. This model is an expected value simulation, but I'm going to show you how to run one-way sensitivity analysis and tornadoes using for the expected value, but you can also do it for microsimulation models too. So if this model happened to be a microsimulation model, I would just select this box here, and it would then run the microsimulation model and do then the sensitivity analysis on those, so the one-way sensitivity analysis on that. Okay, so it's as easy as checking the box for one way if you've got a microsimulation model, and I'll show you how to do that for a tornado diagram as well, which you can do as well. So now you've set your range, so going from the low entry of 0 to a high entry of 0.5 with a number of intervals, just select OK. And we'll have a look at what the output looks like and what that means. Okay, so you can see here that the results are presented as a text report. And the results are going to show you how, sorry, the text report shows you how your results change across the parameters uncertainty range. So we've got the first column here, which is the variable that we're changing, so the parameter, which goes from 0 up to 0.5. And then for each strategy, you've got the cost and effectiveness that's given. So the next column there is given for your strategy here, okay? And in this particular model, as we've run it, the order of the strategies change with the least costly presented first, and that's kind of what happens by default. So in this first example, within disease prevalence is 0, so no one's got the disease. Treat none is the least costly, and that's presented first. And then as you progress down, you'll see that biopsy becomes the least costly, so that's presented first. And then as the prevalence gets higher, then treat all is presented first, because that becomes the least costly. Okay. So you can see that the optimal strategy for each set of rankings, either by examining the ICEs in order or by looking for that strategy with the highest net monetary benefit. So that will tell us what the optimal strategy is. Something that's fairly new is this link here, so being able to change the order of the strategy. So in this case, they change based on the least costly, but some people want to set them to a custom order, so the same order all the time. So you can select to do that. And then these will be reordered so that the strategy is always in the same order. And then you just have to decipher the ISA value here and the net monetary benefit again to give you which is the most appropriate strategy, so the recommended strategy for the value of the disease prevalence that you're looking at. So the most useful graph that we can look at over here on the right-hand side, you've obviously got a link to a number of graphs. The most important one is listed at the top here. So this is the net benefits. So that is going to show us if there's any cost effectiveness thresholds in what we're looking at as well. So if we select that, we have to enter a willingness to pay because it's a net benefits graph. We can see that in this particular example, there is a threshold, so whereas we go from one strategy to the other. So as the disease prevalence is really small, we treat none initially, and then as the disease prevalence gets to 1% of the population, then the preferred strategy becomes biopsy. as you continue down here. Okay, so that's just showing you how the how the net monetary benefit changes as the disease prevalence changes over your range of uncertainty. So in our model, if our disease prevalence that we'd looked at was really small, then maybe we'd do a little bit more work to get the correct number there. So when you go back to your original text report here, you can see that all of these graphs here basically present the variable that you're changing. So in this case, the disease prevalence versus other values. So such as this graph here, which reports it against the average cost. So how the cost changes as your disease prevalence changes. Okay. Okay, so you can see there again where you've got changes there between different strategies as your disease prevalence changes versus the cost here. Okay. All right. So we'll go back to the, well, I guess one more thing to say from the sensitivity analysis is that obviously you can export these results easily again to Excel. So just click the Excel and those reports will be nicely outputted into Excel for you as well. All right, so just going again back to the model, you can choose to run the analysis and looking for 2 or 3 variables changing at the same time as well. So again, go back to sensitivity analysis. You've got the two-way option here. In this case, you'd need to select 2 variables. This just happens to have disease prevalence and test specificity as the 2 values here that you're looking at changing. You just select OK. And the output of this is going to be a graph where the different colors that you've got in this graph basically identify which is the optimal strategy, i.e. the one with the highest net monetary benefit. So the coloring is the net monetary benefit. So for disease prevalence being small and then the test specificity sort of over this range, treat none is the preferred strategy here, whereas in this area here, biops is the preferred strategy. And again, you can select the text report to see all the values in here that give you those results. Okay, and those can be easily exported to Excel again. So that's how you do 2-way, and also obviously 3-way would be similar as well. All right, so the next thing that I want to show you in terms of deterministic sensitivity analysis is looking at the relative effect of individual parameter uncertainties, and we do that via looking at the tornado diagram. So what the tornado diagram will enable you to do, I guess this is the most important part, is to run a set of one-way sensitivity analysis on the model for a given set of parameters. So TreeAge supports various different types of tornado diagrams. There were some updates done sort of during last year to upgrade the tornado diagrams, and there's also been some more recently done as well in the July release, so a few weeks ago. So if you haven't got 2018 release 2, I suggest, well, you can upgrade so that you can actually see some of the things that I'm going to show you today. So again, to generate your tornado diagrams, I'm just going to close all the other tabs in here. And so we just select the root node, you go up to analysis, sensitivity analysis, and you want to select the tornado diagram here. And then it will give you a list of variables within your model that you can use to generate your tornado diagram. So if it's the first time that you've done that, usually what would happen is all your variables will be listed, and you can select them and either remove them if you don't want to do the tornado diagram and a sensitivity analysis on them, or if they're not listed, you have the option to add them. So all 5 that we have in our model here are added in, but these buttons here will allow you to add or remove them as you go. Okay, so as with one-way sensitivity analysis, again, you can see here that we've got the variable and then the type, and that means how we're going to vary the parameter over a range for doing the sensitivity analysis. So in this case, disease prevalence is by value, and it goes from 0 to 0.5 with 4 intervals. But other values you've got in here, so probability of being blind or probability of blind being treated, we're adjusting those by percentages up and down. And then the other ones here we've got by value. So you can use a combination of those as we go. So the model that I've got is actually already set up suitably to be able to run. Importantly, I guess someone answered this question. If your model is running as a microsimulation model, all you would do is select this box here, and then you'd be able to generate the tornado diagram for the microsimulation model. And that's a new feature that's been added just a few weeks ago as well. Okay, so let's just, with these combination of parameters, select OK. And then I'm going to talk you through the tornado output that you get and all the different kind of tornado reports that you can see. Okay, so you can see here there's a lot of different report options. It tells you the number of strategies and variables you've got, then your report options, and then depending on the report options, this box over here on the right-hand side will change. Okay, so the first one that's checked here is your ISA tornado, and what that's going to do is report the range of ISAs generated for each parameter's uncertainty range. And because the ISA calculations require a pair of strategies, you obviously need to select a pair of strategies here, okay? And you use this particular tornado if you want to look at the relative impact on cost effectiveness relative to two strategies that are generated by the parameters and their uncertainty ranges. So in this case, we're going to choose tree to all and biopsy as the two values for the ISA range. And then all you do is when you've selected the settings or set them to whatever you needed to based on your tornado diagram, you select open report and it opens a tornado diagram for you. So all of the tornado diagrams will be presented in a similar kind of format to this. So I'm just going to take a minute to just orientate you to that. On the left-hand side here, you have a pane for chart settings. It allows you to easily edit the title, to show or to hide the legend, to give appropriate labels, change the numeric formatting, color the bars, which we'll talk about in a moment, show the expected value line, etc. And you just hit apply to change any of those things that you need to as you're going along. So in the middle is obviously the main tornado diagram. And then on the right-hand side, you've got a list of all the one-way sensitivity analysis reports that have been generated. And we'll look at those in a moment as well. Okay, so let's look at the tornado that's in the middle here. So you can see this is the ISA tornado for biopsy versus treat all. And you've got some blue and red coloured bars here. And this colouring is quite nice in the tornado diagram because it shows that how the parameters uncertainty range changes from the low part to the high part and how that relates to the ISA changing. So your axis along the bottom here is your ISA, and you have a dotted line up here which indicates the base case value. So your expected value here was 473.94, if you remember, of the base case that we had, excluding dominated. So we'll look at a couple of different parameters here. The blue portion of the bar is going to represent the low part of the parameter range. So that would be this case here, whereas the red part of the bar indicates the high portion of the parameter range. So when the blue is on the left, like here, the probability of blind with no treatment, and then the red is on the right, the ISA increases as the parameter value increases. So the ISA is going up, this parameter is also going up. When it's flipped the other way around, so the blue part is on the right and the red is on the left, then it means the ISA is decreasing, so moving to the left, as this parameter is increasing. So the colouring kind of helps you see how these values are changing. So with 0.75 over this side and 0.99 over here, whereas it's the opposite way around for the other one you've got down here. All right, so that kind of gives you a little bit of a feeling for how those variables are changing as the and then the impact that that's having on the ISA. The other thing that's really useful is you can actually see this by looking at the one-way sensitivity analysis. So if you get confused and you forget kind of which way they are around, we can look at the one-way sensitivity analysis that we've got here. So for example, we can select this test sensitivity, which is the first variable here. And we said that in this case, the value of the test sensitivity was increasing as the ISA was decreasing. So we expect that graph to be showing that the ISA's increasing as test sensitivity is decreasing. Whereas for the other value that you've got down here, which was the reversed option, you can see that the graph is going to go the opposite way. So the P blind increases as the ISA increases. So the blue is on the left and the red is on the right. Okay, so those links to the one-way sensitivity analysis as well can kind of help reinforce your understanding of the tornado diagram that you're looking at. Again, on the right-hand side, you've got a text report here, and it gives you the statistics around each variable. So it will tell you how the ISA changes with the parameter value. Okay, so it tells you the variable that you've got at the top is the one with the highest impact, the biggest spread, and as you go down to the bottom one, the one with the lowest spread as well. So it just gives you the statistics around that. And again, easily exportable to Excel. Right, so that's the ISA tornado diagram there. We'll look at a couple of the other tornado diagrams that we've got. So for the next one now, which is the net monetary benefit tornado, it reports the range of optimal strategy, net monetary benefit, generated for each parameter's uncertainty range. And you need this tornado because you can quickly see which parameter ranges generate cost effectiveness thresholds. So, we were talking with one-way sensitivity analysis, we looked for cost effectiveness thresholds. This will allow you to do sort of several at the same time. Obviously, because it's a net benefits, you'll need to enter a willingness to pay, which in this case is set to 30,000. And we'll select open the report here. So you can open the report, and then you can see here that we've got a sort of a set, the range of different values that we've got down here. So again, the layout is the same as for the ISA tornado with the chart settings on the left, the tornado in the middle, and the actions on the right. And in this case, we've got a different color bar for each variable. So what this one indicates is the variable at the top has the biggest impact on the optimal net monetary benefit. But you'll notice that there's a black line in here, which also indicates that there is a threshold for this variable where the optimal strategy changes. And so you should be able to see that by selecting that same variable here. And you can see here that, yes, there is a threshold change, which is there. Okay, so that was the one that gave the threshold change. Okay, so each net monetary benefit bar that you have here, there may be one or more bold lines in it to indicate where there are thresholds. Many modelers prefer this ISA chart because it looks at relative change in cost and effectiveness between a pair of strategies. However, the benefit of this one is that it can include all strategies and all thresholds. So again, all you would do is click on the secondary reports here to see what was really going on within each of the individual variables. Because we're almost out of time, I'll just quickly show you the incremental net monetary benefits as well. So you have to again select a pair of strategies in here to look at, and that's going to report the range of incremental net monetary benefits generated for each parameter's uncertainty. And what that does is it will give you a measure of the ISA. So if a pair of strategies have 0 incremental net monetary benefit, it means those strategies are equivalent. So it can be helpful in scenarios where the parameter change causes the incremental effectiveness to pass through 0. So you can, choose different pairs of strategies to report. You can see which ones sort of have a big impact. Let's go and see if we can pick a different pair. Okay, so you see some of them have really little impact down here. Okay, okay, so that's the incremental net monetary benefit. A couple of additional charts which have been added as well recently are the incremental cost or the incremental effectiveness. Both of these will allow you to isolate the parameter impact on either the incremental cost or the incremental effectiveness. Again, you need to select a pair of strategies indicating which one is the comparator and which one you want to use as your baseline. And then if you look at cost only or effectiveness only, these one are going to ignore all the other rewards in the outputs as well. So not looking at comparative or relative strategies as well. And then obviously for each of the things that you've looked at as well, you'll also have access to the rankings report as well available. So all you do is via this tornado diagram, you can just select any one of the variables, and again, you can generate your rankings report as it was a one-way as well. So the tornado is really, really a good method to run lots of one-way sensitivity analysis at the same time. So that's kind of a quick blitz through deterministic sensitivity analysis. I guess in conclusion, what I'd say is that uncertainty analysis is important for all models, especially looking for thresholds. And even if there's no thresholds, there may still be a strategy change due to some uncertainty related to several variables changing. So while there might not be any changing strategies for individual parameters varying deterministically, you should always consider, as well as an option, probabilistic sensitivity analysis as well. So looking at combinations of parameters changing, and we'll cover that in the next webinar that we do. So I'll probably just, because there's not that many people on the line, I can probably just unmute everybody potentially, and if anyone's got any questions, feel free to either post it to the chat or just talk out loud. If I don't know if I can hear everybody or not, but yeah, so let me know if you have any questions. Otherwise, thank you all very much for joining, and the webinar will be posted on the website, so if you want to review it again, feel free. Any questions?
Belinda, it's Lily here.
Hey, Lily.
Hey, can you, you know, with the one-way sensitivity analysis, if you show that chart, or the tornado chart with all the one-ways, oh, not that one, sorry, the tornado chart for that one there, yeah. Is there a way to show what the value of each parameter is in the base case in your chart? So it's obvious when the whole bar is blue that you're putting in the higher, you know, that the base case contains the higher value, and if the whole bar is red, well, you know that it's the lowest value. But for the ones where there's a range and the value in the base case is somewhere in between, is there a way to show what the value is for the base case in the actual chart, so you can see what?
So in here,
so test, so what for test sensitivity, you can't actually tell what the base case value is.
Okay, so yeah, you can't tell from viewing this. I guess that's just known from your base case report. Would that be useful to have the base case value on there somewhere? I don't know if there's a way to add that in.
I think it would. Yeah, that's what I was thinking. Is there a way to put it in?
Yeah, I don't know that.
It makes interpretation a bit easier.
Yeah, okay, so because I guess we're assuming that you know what the base case values are, but yeah, as you say, you know, this is actually, I can't remember what it was now, but say 0.9, and it's kind of unevenly spread around, so you can't kind of guesstimate what that should be. I don't think there is a way to do it from here.
Okay.
No, okay, so that's, I take your point on board, and I can certainly recommend that. That's something that you'd like to do. It should be relatively easy to add a checkbox here that would say show base case value as well. Okay. Thanks for that. Anybody else have any questions? Okay, if anyone thinks of anything after, feel free to email me. Thank you all very much for attending. It's been great to see you as well. Okay, all right. Thanks everybody.